Catia. So here the Catia is open. Now I will open new document, product, and the product is opened. First of all, insert object, existing component, select the product into which you want to insert the existing component, and now let me go here, the bottom plate. I will call bottom plate first. So you can let me remove this first. You can see all the constraints are unhighlighted still, as there is no component in assembly workbench. Now I'm going to call one component, which is bottom plate, and you can see few of the constraints get highlighted. In tree, there is no constraint tab. The first component will be fixed. So here is the fixed constraint. Select it and select the part which you want to fix. Bottom plate I want to fix. Here is a fixed constraint. Apply to the bottom plate, and in specification tree, here you can see the constraint tab is get open. In with the first constraint is a fixed constraint. Now I am going to call one more component. Select product one and guide pillar. Here is the guide pillar. Let me move by using the manipulating commands. Move in Z direction or move in Z explain here. Now I want to constrain both of these. For that, as we discussed in presentation, we will give coincidence constraint between guided pillar and whole of the bottom plate, and just update it. Rate constraint. Still there is a free degree of freedom over here. You can restrict it, you can check it degree of freedom by using manipulating toolbar. Check here, click on the checkbox with respect to constraint, and then try to move in XYZ direction. Select and move. It will not move in X direction. Try to move in Y direction. It's locked. Try to move in Z direction. Oh, it's still open. It's still open. So now we will apply the mate constraint to restrict the moment in the Z direction between the bottom of the guided pillar and the bottom of the bottom plate. Here is my mate constraint, offset constraint, or contact constraint. In offset constraint, we have to give the offset between the two is 0. In contact constraint, it will automatically become 0. And then again, it inserts in opposite direction. So go to the constraint, double click on constraint, click to more, and reconnect it. Or this can be solved by using the mat constraint. Mat this face to this face, and you can choose from here opposite or same. I choose opposite, 0 degree of offset, and just update it. Now it's perfectly free. So this is going in downward direction, this is in upward direction, that's why opposite. If I pick both the same, this guided bar will go on the downward side as it was before applying constraint. Now let's again go to manipulating. Now we know that XYZ moment is get restricted. Now we will check about the rotational XYZ moment. Rotation about X is get restricted. Select Y and try to rotate about Y. it also get restricted. I am not able to rotate in Y direction. Now Z. Yes, yes, yes. It's rotating about Z. You can see here. This line, the torrent line, is get rotating. So means we have to restrict this freedom too. For that, we'll go and select any one of the plane of the guided rod or guided bar. Let's say X plane, and the angular contact between X plane of the guided bar to this. I think X is the top one. Let me unhide all the planes first for the guided bar. Okay, now X is the top one, which is not required. YZ or ZX may be useful for us. Go to angle constraint, ZX plane with this face of the bottom plate, and the angle is a parallelism. Instead of giving angle, give parallel, and okay, and then go to update. So it's updated. Now all the degree of freedoms get restricted. It is fully constrained. Now go to the existing component, select the product and call the guided bush. Similar to this guided bush, first let me manipulate it to some of the place. Okay, now we'll go first for coincidence constraint between bush and the pillar. Mat constraint on the top face of bush and top face of guided pillar, both in the same direction. Okay, and the offset will be the 0, and then update it. Still there is a 1 degree of freedom for bush. Yes, that is a 1 degree of freedom. Let me hide that plane for the guided bar so it will not create confusion now. And now I will unhide for bush and give the similar kind of constraint, this plane, this plane, and make both the parallel and say okay. Again hide this. Okay, so this is final. Similarly, I am going to call second pillar and the bush. Existing component, select product, guided pillar. Oh, where is it? It's placed at the same place where the first pillar was. So, required to manipulate it. Yeah, it's highlighted. Now remove and shift it to other place, and now start to give the constraint, coincidence constraint between the pillar and the hole, and mate constraint between the bottom face of bottom plate and bottom face of pillar. Both are in the same direction. Say okay, update it. Now, as we know the XY, except XY plane, we will select any of the plane. Let me select now this surface, this plane, parallel. Okay, so this is fully constrained. Now I am going to call the bush. Existing component, product, bush. Now bush is there. Imported data are those one in session, but they have modified in Catia session, have a last modification. Means both the data are there here in the session. It's saved. You call it again. Now I am applying constraints to both pillar and the 0 degree. And now I am going to apply my last constraint, parallelism, this plane with the surface of the bottom plate, and make it parallel. Now say okay and update. So this, I think, clear up to this. Now I am going to call the last component, last part of my assembly, which is top plate. Existing component, select on existing component, select the product, go for top plate. The same constraints that we give between the guided door and the bottom plane, now we'll give the same constraints to top plate and the bush. First coincidence, this bush axis to hole axis mate between this plane to this plane 0, and I will give one more constraint, coincidence of this bush to this, and update. So this is fully constrained and my assembly is get finished. And here are the total number of constraints that I have used to make the assembly of these components. I will hide it. I'm going to hide the constraint so that I am able to see the complete assembly. Now I am going to create a section view of this and move it. Okay. So here you can see the section of bottom plate, guided bar, bush and the top plate. Okay. So here we have completed our assembly. Now I am going to explore this assembly, all level, product 1, and a fixed product is this one, and I am going to apply it. So get explored all the components. Slowly, 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 slowly. Explodes all the components. This is the exploded view of my assembly. I can even move all the components by putting and go upward. Okay. I'm going to put over here and move again up. So this is my exploded view. Now put to its place. This is my exploded view of the assembly and say okay. Yes. So here we have finished our assembly tutorial. Let me save this tutorial, save file, save to the folder, save and close it.